In this lecture, we will see the different types of supports which are generally used in a truss, the degrees of freedom of each of these supports, and how the numbering scheme is done for each truss element. Let us begin with the support. So the first one we have is the fixed support. In the fixed support, we know that the truss element is not allowed to move in any direction. So all the degrees of freedom will be 0. Next, we have the roller support. So in this support, we know that the support can move along the direction indicated in the red. So the horizontal displacement is allowed in this type of support. So we have 1 degree of freedom. Similarly, if we have a hinged support, H is not allowed, that is horizontal displacement is not allowed. V is also not allowed. So vertical displacement is also not allowed. Okay. And we could also have a roller support like this, which allows vertical displacement as indicated by the red arrow. So we will have vertical displacement in this type of a support. So this you need to remember while solving your problems. Next, we move on to the sign conventions used. Now, if we have a bar element like this and we label it 1 and 2, we remember the degrees of freedom that we had done in the previous video, and we said that if there is a node which is named j, then its displacements will be named 2j minus 1 and q2j. So for node 1, we will have q1 and q2, q3 and q4. We have to measure this angle here, theta. So let us adopt this sign convention. Theta is positive if the angle measured with respect to the x-axis is anti-clockwise. And theta is negative if the angle measured is clockwise. An example of negative theta would be, so we have a global axis x, y, and we have a bar element which is in this direction. So as we see here, we are measuring this angle theta here in the clockwise direction. So in this case, theta will be negative. Now, it also depends upon which one we consider the first node and which one we consider the second node. Now say we have a truss element like this, and we decide that we want this as node 1 and this as node 2. So we place our reference axis at the first node. Okay. Now in this case, our theta would be negative. Note that it is the same bar element as this case here. It's the same bar element, only my numbering scheme has changed. So I decided to take the top node as the first node and the bottom node as the second node. I have reversed the numbering scheme. So this becomes negative. Also, now let us take, this is an inclined truss element. Let us take a straight truss element, a horizontal one. So we have node 1 at the left hand side and node 2 at the right hand side. I place the x's at the first node, reference x's, and this angle here, since the bar element is coinciding with the x-axis, our theta here would be 0. The same example, now I am taking this as my first node, the right hand side is the first node and the left hand side is the second node, and I have to place my reference axis at node 1. Here, this is my angle theta, and theta is positive 180 degrees. The angle is measured anti-clockwise, that's why it is positive. So this is the numbering scheme that we are going to adopt to solve all the problems of Truss. Thank you.